Hello Jackdaws and Ravens, we're back with another maths video, and this week we are starting off with comparing fractions. So you might be asked the question, which is bigger, 3/10 or 7/10? And luckily the denominators are the same in this question, so we need to think, if someone was offering us 3 slices of a pizza or 7 slices of a pizza, which one are you going to get the most pizza? And you should all be saying to me that clearly 7/10 is bigger than 3/10, and we can compare them like that. Remember, our symbol always needs to face towards the bigger fraction, like that. Okay, so when the denominator is the same, you simply need to look at the numerator to decide which is the bigger portion, which is the bigger part. But the denominators are not always the same. So what if you had 5/10 and you were comparing it with 3/5? Now, our denominators are not the same and our numerators aren't the same. So what do we think we need to do to compare fractions with different denominators? And I've got with me today some Cuisenaire rods to help us show this. So here is my whole. This orange bar shows my whole. And first, I'm going to split it into fifths. And just to show you that it is the same whole, I've just split it into fifths, or 5 parts, like that. And I've got 1, 2, 3, 4, 5 parts, so I've got my fifths there. But our question has fifths and tenths. So we also need to think about, what if that whole, that orange bar, was split into 10? And I've got my tenths here as well. Okay, now we've thought about our whole and we've split it into 5 and 10. The question was 5/10 compared to 3/5. So 1, 2, 3, 4, 5. There's my 5/10. What is 5/10 also equivalent to? Remember those facts I told you just need to sort of start remembering and using? 5/10 we can also say is a half, because 5 is half of 10. So 5/10 we can also say as a half. So I've got my 5/10 here, or half my bar. Can you see that? It is half of my orange bar. And what about 3/5? So I've got 1, 2, 3, 4, 5. Got my 5/5 there. What if I've only got my 3? If I put them together like that, make sure they're lined up. Now, can you see which is the bigger fraction? Which do you get a bigger part of the whole with? And you can see that 3/5 is bigger than 5/10, or a half. So we can compare our fractions like this, putting in the correct symbol like so. All happy so far? I'm going to give you another one. And I've got 2/5 this time compared with 7/15. Again, we've got different denominators, so we need to think about it visually, like using the Cuisenaire rods, or if you had some manipulatives, you might be able to do that. But we can also use the method we use when we were doing equivalent fractions, and we could make the fractions have the same denominator. So I'm going to put both of my fractions into 15ths. So I'm going to focus on my 2/5 for a moment over here. And I'm going to do 2/5, and I want to put it into 15ths. So who can remember, what were we doing when we were doing equivalent fractions? What do we need to do to convert the fraction? And we need to spot the relationship between the numbers given to us, and we've got both the denominators here. So what is the relationship between 5 and 15, or what do we have to multiply 5 by to get 15? And the answer is 3. 5 times 3 is 15. And whatever we do to the bottom number, we need to do to the top. So we need to do times by 3 at the top. So 2 times 3 is going to be 6. So then can you see what I'm actually comparing now? Because we've converted it into this having the same denominator. We're actually comparing 6/15 with 7/15. So which one is bigger? Remember, when the denominators are the same, we can simply look at the numerator to see which is the bigger share, or the bigger part. So 7/15, 7 is bigger than 6, so 7/15 is the bigger fraction. Okay. What if you had the question 1/6 comparing it to 5/18? Which of these is bigger? Now again, different denominators, so we need to put them in the same denominator. You need to think of it like if you had different denominators, you've got different fruits. It's like trying to compare apples with oranges, and you can't do that. So you need to put them into the same denominator so you can compare them directly. So I need to change or convert one of my fractions, and I'm going to convert my 6ths into 18ths. So I'm going to come over here and do like we were doing with our equivalent fractions. I want to put 6ths into 18ths. So I'm going to go 6 and 18. What's the relationship? What do we need to do to 6? What do we need to multiply 6 by to get 18? And your times table knowledge should tell you that it is times 3. 6 times 3 is 18. And then the rule with fractions, whatever you do to the bottom, you need to do to the top. And then 1 times 3 is 3. Then we can go back to our original question. And we are now comparing, no, we are actually comparing 3/18 because we converted our 6th over here with 5/18. And which one is bigger? If someone's offering you 3 or 5, you would definitely go for the 5 to get the larger amount. So 5/18 is bigger than 3/18 or a 1/6, like we know it is. Different type of question now. Sometimes you will be asked to order a group of fractions and put them in either ascending order or descending order. Who can remember which is which? Ascending is going up from smallest to biggest, and descending, like you're descending the stairs, is going down from the biggest to the smallest. So I'm going to put a group of fractions on my whiteboard, like so. There is my group of fractions, and the question is, I'd like you to put them in ascending order. Ascending order. I'll jot that there to remind you. Pause the video and have a think about what you would do, because straight away you should notice the problem of whether we've all got different denominators. So pause the video, think how you would solve this, and then come back and check in to see the answer. So I'm looking at these fractions. They've all got different denominators. But I know that I could convert them and get them all with the same denominator so I can compare them directly. So I am going to choose 100 because 2 of my fractions are already in 100ths, so that's less work for me. And I can see that 10 goes into 100 and also 50. So first let's do our 3/10. So you need to imagine you're putting 3/10 into 100ths. Now, what do we do to 10 to get 100? We multiply it by 10. Need to do the same to the top. So 3 times 10, and it's going to give us 30/100ths. So 3/10 is the same as 30/100ths. So I'm just going to change that fraction there. What was the other one we needed to convert? And that's right, it's 14/50ths. Again, we want to put it into hundredths so we can compare them all directly with having the same denominator. So what do I need to do to 50? What do I need to multiply 50 by to get 100? And the answer is by 2. So I need to do the same to the top number. And I've got 14 multiplied by 2. I could do this partitioning. And I could think 4 times 2 is 8. So I'm going to put an 8 in my ones. And 1 times 2 is 2. Or 10 times 2 is going to be 20. So 14 times 2 is 28. So again, let's change our 14/50ths into 28/100ths. Pause the video. What order would these fractions be in if you put them in ascending order? And you should see 26/100ths is the smallest numerator out of the 4. So that is our smallest fraction, 26/100ths. What's going to come next? 28/100ths, 30/100ths, and finally 32/100ths is our biggest fraction. And that is how you would tackle a group of fractions like that and putting them in ascending order. Have a go at the worksheet today. You've got lots of different style questions, but it's all about comparing them. And just remember, you cannot compare fractions with different denominators. You need to convert them and make them have the same denominator. Best of luck. See you tomorrow.